Okay, so we're going to look at some more examples of integration by parts. The first thing we're going to do is we're going to fix this problem really quick because I was wrong when I typed this out originally. In our denominator, we want e to the positive 2x power, not e to the negative 2x power. You'll see exactly why in a second. So this, I'm going to tell you, is an integration by parts problem. You're looking at this and maybe thinking, I'm going to just believe you. Fair, but we need this to be a multiplication problem. You might be thinking I'm crazy because it's not a multiplication problem, but we can change it so it's a multiplication problem. So what we're going to do is we are going to be using our exponent rules and changing stuff around. And you will be it'll be very obvious of why I made the mistake I made. So we are going to change that e to the 2x and make it not in the denominator anymore. In order to do that, we are going to change that exponent from a positive 2x to a negative 2x. This means that we have x squared times e to the negative 2x power. We now have multiplication, so we can for sure use integration by parts here. So we now need to pick a u and a dv. This one, we want to make x u, we're going to make e to a power dv. Generally speaking, when we see e to the x, we want to make that dv every single time. So we're going to make u equal to x squared. We're going to make dv equal to e to the negative 2x dx. The derivative of x squared, we get du is equal to 2x dx. The integral of dv, we have v is equal to. In itself, this is technically a u substitution problem. But I know if I were to take the derivative of e to the negative 2x, I'm going to have e to the negative 2x in my problem, so e to the negative 2x is going to be in my integral. If I take the derivative e to the negative 2x, I also need to take the derivative negative 2x. The derivative of that would be negative 2, so I'd have a negative 2 floating around here. I don't have that, which means something had to have canceled out with it. In order to make negative 2 go away and become 1, I need negative 2 times negative 1/2. So this negative 1/2 is going to be a coefficient in my problem. So I now have my u, my v, my du, my dv. We're going to go ahead and plug this in. So I have u times v, so x squared times negative 1/2 e to the negative 2x minus the integral of negative 1/2 e to the negative 2x times 2x dx. Okay, we're going to simplify this. So I have negative 1/2 x squared e to the negative 2x. And we are going to subtract, but I'm going to pull out these constants. We have a 1/2, we have a 2. So these two right here are going to combine, 1/2 and 2 to make 1. We're also going to pull this negative out. We have a negative 1 times this subtraction. So we are subtracting a negative, which means we are now going to be adding. So we are adding this integral of, I've gotten rid of a ton of things now. So we have x e to the negative 2x dx. You may be thinking, if we were to take the integral of this, using u substitution, we would still have an issue, which means we still need to use integration by parts. And you would be right. That means we need to do integration by parts again. So the only thing that we're going to be doing integration by parts on is this integral right here. So we're going to pick a new u and a new v. So in this case, u, we're going to stick with x being our u. So this time u is equal to x to the first power. dv is going to equal the exact same thing it was equaling before. So e to the negative 2x dx. The derivative of x is 1 dx. And we have done the integral of e to the negative 2x dx. So we know it is negative 1/2 e to the negative 2x plus c. So now we're going to go ahead and plug in what we have. So this first piece here, negative 1/2 x squared e to the negative 2x, stays the same. We're going to be adding our new integration by parts. So u times v, so x times negative 1/2 e to the negative 2x minus the integral of v, negative 1/2 e to the negative 2x times 1 dx. So we're going to simplify what we can. I have negative 1/2 x squared e to the negative 2x plus negative 1/2 x e to the negative 2x. Very similar. The only difference is one's x squared, the other one's x to the first. And then we are going to pull out this negative 1/2 as a coefficient. We have minus a negative, so we're going to be adding. So plus the integral of e to the negative 2x dx. So we're now going to do the integral of e to the negative 2x dx. That sounds familiar. It is the exact same thing that we have been taking the integral of. So we're now just taking the integral of e to the negative 2x, but it is actually in our problem as a final thing. So now we don't need to do a ton of extra stuff. So we have negative 1/2 x squared times e to the negative 2x power. We're going to go with minus 1/2 x e to the negative 2x. And then we know that e to the negative 2x's integral is negative 1/2 e to the negative 2x plus c. Sometimes when we look at problems like this, we have to do integration by parts multiple times. Thankfully on the AP test, if they do, they will only make you do it twice. They wouldn't make you do it more than that. But they might not even make you do multiple times at all. You just have to know that it is a possibility. It is something they could ask you to do. The only other thing we might do is simplify this, so factor out what they have in common. So I might factor out a negative 1/2 and everything else. And I even dropped a 1/2, so we're going to put that 1/2 back in. So we're going to factor out a negative 1/2 and an e to the 2x, an e to the negative 2x from everything. This means I have an x squared minus an x, but we have gotten rid of that negative, so now it's x squared plus x plus 1/2, and then finally a plus c at the end. So the whole reason why we wanted to make x u is so that way that x squared can go down a level, and then when we did it again, x would go down a level, so then we would have it where we need it to be. So I mentioned this a little bit ago. Why have we never looked at the integral of the natural log of x? That's because in order to do this integral, you have to do integration by parts. And you might be thinking there is no multiplication here at all whatsoever, but there actually is. That multiplication that we're looking at here for this integration is the natural log of x times dx, or times 1 dx. So we are going to be making u, like I said, natural log is always u, natural log. Our dv this time is going to just be the dx. We take the derivative of u, we have 1 over x. We take the integral of dv to get v is equal to the integral of 1 is going to be x to the first power. So ultraviolet, u times v, so we have the natural log of x times x minus the integral of v times du, 1 over x dx. So we're going to simplify this a little bit. Natural log of x times x minus the integral of x over x dx. Well, x divided by x, or even x times 1 over x, is going to give us the same thing. That's going to give us 1. So we're really looking at the integral of dx again, or 1 dx. This means we have x times the natural log of x minus the integral of 1 is x to the first plus c. So when we look at this integral of natural log of x, its formula is x natural log of x minus x plus c. But it's really hard to understand where this formula comes from because we need integration by parts in order to even do anything with it. This is why you guys didn't learn about the integral of natural log until now.